Hey everybody, this is Larry, this is me going Q2 of the weekly contest 433, count the number of computer unlocking permutations. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one, I'm a little bit sad because I had a typo when I submitted it, and it cost me an extra wrong answer of 5 minutes. This one is also like a little, or maybe a lot awkward in the sense that, I don't know, I kind of knew the answer right away-ish, but I wasn't sure because this is just like a way, there are a lot of words, right? But the answer is just apparently n-1 factorial, if it's possible. And there are a lot of things going on, but the reason why it is n-1 factorial is because it all only depends on computer 0. If the computer 0 can unlock any machine, and the way that you can maybe think about it is that there's like this transitive property that the function adheres to, right? There is this transitive property that goes with this like decrypting or whatever, which is to say that if A unlocks B and B unlocks C, then A unlocks C, right? So as a result, you can actually do them in any order, right? Because then now, if A is good, then we can actually even do C and then B and then C, however order, right? So that means that the only thing that matters is the first computer that you unlock. So the thing that is only 0, which is the impossible case, is if the impossible case is if the 0th is equal to or less than any element. Otherwise, it's 0. Otherwise, then you have n-1 elements that you could put in any order, so that's going to be n-1 factorial. And I just kind of wrote it out this way with a mod, and yeah, and that's it. This is O of n, right? Because we look at each element once, and then we also multiply each number once with a mod. So yeah, that's all I have for this one. I mean, you see that you could see the mistake that I made. I just had a typo. I just wrote n instead for some reason. So I don't know why. Like I don't know. But yeah, just silly mistakes. But otherwise, it's a very weird problem. It's a really like it's a problem where you second guess yourself. I don't know. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. Daisies. So I'm pretty behind now, but that's okay. Oh well, maybe more behind than I expected, but still. Alright, let's go. We could still finish this. People finish this in 3 minutes. I could finish this in maybe longer. Cheaters are so silly. Anyway, you're giving away a complex N, the N-locked computers in a room, unique password, the password to compare, complexity I, password is already decrypted and serves as root. You can decrypt the password for the computer I using the password for computer J, where J is any... Okay. Honestly, that first one took so much energy out of me. I'm trying to read this and not doing so Gucci. Okay, so 0 is the thing, and then we can unlock the other ones. You could decrypt. So okay, so to get I, which has to be later, it has the complexity. Okay, you can decrypt the password for the computer I using the password for computer J, where J is any. Okay, so that sounds reasonable. So for I, if there's a to decrypt the password for I, you must already unlock a computer J, such that I mean those two are kind of saying this, not the same thing, but in a weird way. Okay, find a permutation in which computers can be unlocked. Permutation mod. All right. Okay, let's see. Complexity. Alright. Alright, let me get a water real quick. There's some like weird topological sort-y thing. Okay, so we start at 0, and then we go to any number that is later but bigger. Right? I'm trying to even just understand this, to be honest. Alright, so from 0, it goes from 1 to, and then it goes to any number that's higher to the right. Right? And because you can do all of those, it basically has like, okay, but what if it can't? I'm kind of confused about this one, honestly. It's a little bit awkward. And this one is because you can't unlock these two at all, but you can decrypt the password for using. Okay. Yeah, I mean, I guess n factorial is probably not gonna be good, but we have two numbers. Is it just I don't get it. Is it just n factorial and not? Because no, I get so there's some like inverse thing. I just don't get this one. It's either it's possible and not, but is that true? Because by definition, if this is possible, then the first computer can decrypt everything, right? Like, why is that not true? If the first computer cannot decrypt everything, then because everything is transitive, right? Am I just confused? No, it's not quite that. Oh no! It's still, you could always unlock using the first computer, right? So I think that's the part that I'm just a little bit confused about. So maybe that's right. I don't know. So then that means that for I in range x in for I in range of n, right? Oh, let's start at 1. If complexity of I is less than or equal to complexity of 0, then it's just not possible, right? Then we return 0. Otherwise, then now it is just yeah, otherwise this is just, am I going nuts? I mean, it is a Q2, so it could be that this is this, but that is just a very silly problem. That's why it's a little bit weird. But YOLO submit? Nope. Maybe I don't understand this. Wait, oh man, I didn't even get the input right. But there should have been, why do I have such a bad typo, Larry? Okay, so you have n is 3. So 3, why is it not just 2? 1 all times 1 all times 2, right? Am I just bad? Okay, well, alright. I mean, if I didn't have a silly typo, that would have been, you know, not so dumb. But today I am a dumb boy. So, alright, let's. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest, this video, these problems, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later. Take care. Bye bye.